Awesome. Can you guys hear me? It's okay, I'm loud. I don't need a microphone anyway. So welcome to Using Ruby to Automate Your Life. Not to be confused with the next talk, which I highly encourage all of you to go to, which is Using Ruby to Automate Your Home, which is also an awesome four-letter word. And Justin's awesome, so it's cool. I use a lot of four-letter words. Some of them are vulgar, so I'll apologize in advance. Let's get started. So we have this can, and I work for Opscode, and one of our logos is CodeCan. This is not the CodeCan. This is actually a can of the repetitive shit that you do every day. So how many people feel like they're constantly running the same commands just over and over and over again, or you're just doing the same thing over and over and over again? And whether that's like, yeah, Carl, whether that's like making your cup of coffee in the morning or just like cap deploy, like how many times do you hit the up arrow and just run cap deploy a second time? And these repetitive actions are really just a waste of our mind, right? Like we should be really thinking about code and crafting our code, like the earlier talks that talked about craftsmanship and really diving into what we mean. And these repetitive tasks should really be handled by machines. Because there's certain things that humans are really good at, like critical thinking. And there are certain things that humans are really bad at, like repetitive tasks. When we do things, we tend to forget them, we leave things out. It's a known fact that when you do things over and over and over again, sometimes you do them mindlessly. How many people have ever forgot driving to work? Like you have no idea how you got there. It happens to people all the time. Machines don't. You can tell them to do something 1,000 times and they're going to do it right 1,000 times, unless you work in ops, and then you'll disagree with me. And that's cool. So this is the repetitive can of shit, and this is the stuff that you put in that repetitive can of shit, like typing IRB or running guard, or my favorite is cap deploy. And then every once in a while, you'll shove some like operation stuff on top of that, so like tail, like SSH, and then we'll just load up our can of shit with all of the commands. And then on the other side, we have things like creating users, managing security, setting up developer laptops, building websites, maybe not building websites, pushing code to GitHub. These are all things like, how many times do you type git push every day? Or svn, whatever that equivalent command is. Sorry, not hating. So it would be really great if we could automate all, or at least parts of this. If we could give machines more work so that we can think, so that we can really use our minds to build better code. So what if there was a way to do that? This is my can code with a question mark on it. It's pretty awesome. So that's my cliffhanger. But we want something that's going to be reproducible. So we want something that we can continuously apply. Like, I don't want to have to tell the machine to not do something. I want to be able to run it 1,000,000 times. And if it only has to do that thing one time, the machine should be smart enough to know that. If the application is already deployed at the version I need, don't deploy the application again. This is weird. It's going twice as fast. It also needs to be reliable. So I have to depend on my machine. I can't have this like kind of janky script that only works between like 6 p.m. and 8 p.m. because otherwise daylight savings time checks in and then my Jenkins build fails. And if you've ever been there, it's a fun time. And it has to be unattended or untended because attended didn't fit in that thing and it just looked really bad. So I used untended because the thesaurus told me it meant the same thing. And really, like, I don't want to have to tell the machine to do something. The machine should really do it on its own. So I'm going to click this button once. OK, so I'm Seth Vargo. This is my introduction slide. I'm from Pittsburgh, graduated from Carnegie Mellon. I work for a company called Opscode. We make a product called Chef that does a lot of those things that I talked about. And this is how you get in touch with me. So I work at Opscode. That's my email. That's my Twitter and Facebook and GitHub. But I didn't have a cool square icon for GitHub. So that's my GitHub. So go back. This is my disclaimer number 1. I do work for Opscode. We make Chef. But this is not a vendor pitch, so please keep listening. I'm not trying to sell you something. In fact, it's open source, so you can go look at it right now. You can install it on your servers. The second disclaimer is that Chef is cross-platform, but in order to keep this stuff really simple, I've kept it to one platform. There's going to be some code, so put on your code hats. But don't be like intimidated. This only works on OS X because that's not true, or it only works on Ubuntu because that's not true. But I don't want to show you like 500 lines of code to do something on Red Hat and CentOS and Ubuntu and Mac OS X and even Windows, because it takes away from the whole point of this talk, which is to teach you the value in doing this. Cool. So what is Chef? Chef is a configuration and automation management platform whose definition is full of the latest and greatest buzzwords in the industry. So let's really break it down. I don't know why it's going two at a time. So the first thing is Chef is configuration management. So this doesn't necessarily affect everyone in the room, but if you are a Ruby developer and you're a Rails developer, at some point you've encountered a configuration file. Probably the one I would guess is that magical database.yaml that contains your connection information. You may have a Redis YAML, you may have other configuration. Depending on what kind of app you're running, at some point you're managing configuration. And this has a few problems. The first is that from an ops perspective, we don't really want the MySQL or Postgres password sitting in plain text on developer laptops. That's not cool. Developer laptops get left around. There's a backpack sitting here. There might be a laptop in it. If there's a database YAML in there, I now know all of your production passwords. So we don't want that. Really, only the server should know about that, and developers can kind of handle whatever they want. But all too often, I've come into a project and I see the database YAML is just filled with passwords, including the production and staging passwords. So config management is hard. It doesn't affect developers nearly as much as it affects operations people. But with the DevOps movement, we're starting to see kind of a little bit of crossover. So you are managing configurations. They just happen to be for Rails apps and Sinatra apps and not Apache configs and Nginx configs. The next one is cloud administration. How many people work in the cloud? That includes EC2, anything that is not your own data center. Cool. So Chef makes it really awesome to work both in a physical data center or the cloud. But there's additional wrappers and tools around Chef that make it really cool to work in the cloud, especially if you're working in stuff like EC2 or DigitalOcean or Rackspace. You can actually dynamically provision servers and scale and auto-scale using Chef. We're not going to get into that today, but it's kind of like a little exercise left for the reader. Continuous delivery is a really big buzzword in the industry right now. And we're actually going to look at a continuous delivery example in the first scenario that I have here. But continuous delivery is this idea that at any time your application is deployable and that a human is not deploying it. You push your code to source and some build server builds it, and that code is delivered to production at some time and developers are hands off. So it takes a little bit of resilience away from the developers. They just write code and it makes it into production. You don't have to worry about your code breaking production because it goes into a build server. You have really awesome tests. If those tests pass, it gets pushed into production. Otherwise, you come back and you rewrite your code, you fix the tests, et cetera. The last thing, and this is why I love Chef, primarily because I work on our community development team, but Chef is community driven. We have an amazing community. We write community cookbooks, which are the equivalent of Ruby gems in the Ruby world. These are free, public, open source cookbooks that you can download and use in your infrastructure. A cookbook is like a set of instructions. A cookbook might be for Apache or it might be for Ruby. There's an RBM cookbook, there's an RVM cookbook, there's a passenger cookbook, just to give you some examples. And some of these are written and maintained by OpsCode, and some of them are written by community members, some of whom are in the room right now looking around seeing faces. Chef uses a Ruby DSL, so if you're a Ruby developer, cool, you're like 50% of the way there. It's awesome. Normally I'm in a room of people who don't know Ruby and I have to convince them that Ruby's awesome. But you're here, so you know that Ruby's awesome, right? Right, okay. Rachel's clapping, I got it. So Chef is community driven. So OpsCode doesn't have this domineering factor. In fact, we let the community drive. We have an awesome community summit where we let community people decide the direction that Chef will go. It's open source. I said that already. It's github.com/opscode/chef. You can go look there now. It's customer focused, which goes along letting the community drive things. And it's a whole bunch of stuff. OK, it's a whole bunch of stuff. Chef is really whatever you want it to be. You can adopt as much of it or as little of it as you want inside your organization. And we're going to look at two different examples, some of which we're holistically managing, and some where we're we'll just manage a little piece and continue doing things the way that we are. But Chef really exposes and provides some powerful, powerful tools and capabilities. And I like the word stuff because in 4th grade, my 4th grade teacher told me I was not allowed to use the word stuff. And ever since I graduated from 4th grade, I have tried to use the word stuff as much as possible. So it's actually in this presentation a lot. So you can blame my 4th grade teacher for using the word stuff. So Chef lets you do really cool stuff, stuff like provisioning. So a lot of times you have these developer machines, and some of you may be using Vagrant, some of you may be using like VirtualBox or VMware, or you have cloud images, but how many people remember the first day of work when they walked in and they're like, I'm ready to code? And I know GitHub has really worked on solving this problem, but other companies definitely struggle with it, where it's like, well, first you need to install this and this and this, and you need to install that, connect with this service, get your credentials set up, do this other thing over here, make sure you have this password set up. Oh, and you need to talk to the operations people so you can get your SSH keys set up. How many people have ever dealt with that or remember dealing with that on their first day of work? Yeah, right? And I know like an approach that some of the GitHub projects have taken is this like setup script that exists in a setup directory, and it sets up as much as you can possibly set up. And that works for a single project, but inside an organization, it's really hard. You have these access keys and these VPN keys, and I got to get an account over here and a thing over here. Wouldn't it be awesome if I could just walk in, my laptop was ready, it had everything I need, and I could just go to work on the first day? I have all this energy. Like, I'm a new employee. I really want to contribute to the company. All I want to do is write code. But instead, I have to like log into this help desk portal and fill out tickets so that I can get my VPN key set up, so that I can access the data center, so that I can think about possibly deploying code next week. That's sad. Let's fix that. So Chef allows us to provision things, provision our local laptops and provision servers. In fact, you can use the same code. How many times have you run something in development and it breaks in production? If all of your hands don't go up, I'm really disappointed. How many people have ever run code on development and it breaks in production? Yeah. If you mirror your production environment on your local development machine, the probability that that happens is significantly lower. It's not zero, but it's significantly lower. So we can provision stuff. And we can provision developer laptops. Sorry I'm doing this. I'm really weird. But we can replicate your exact production infrastructure on the developer laptop. Most of you probably aren't running Macs in production, but you're probably running Ubuntu or Red Hat or CentOS. So we can spin up virtual boxes or VMware images, or use something like Packer to package multiple images so that we can give you a development machine that looks exactly like production. In fact, we can even load a sample of production data on that machine as part of these scripts, setting up the MySQL or Postgres or Oracle databases for you, so that when you come into your first day of work, you have a developer laptop that you open up, you either fire up a virtual machine or all the data is loaded on there, and you're good to go. You are in a production-like environment, as close as humanly possible to being root access on that production box, like in the data center or in the cloud. And that's awesome, because it gives developers a sense of entitlement and a sense of power, and you're also less likely, like I said before, to have these production-like bugs that sneak in. So then I have a cool infographic that just skipped over. That demonstrates, like, look, those are servers, and then that's a developer laptop. And I hand drew those, and I'm not an artist, so I'm really proud of this slide. So that was the first cool thing that you can do with Chef. And the second cool thing you can do with Chef, again, this is the word stuff, is like maintaining ephemeral staging environments. So how many people have a staging environment? How many people have like a staging environment and like it sits there and like somebody manages it? You can't like make a new one. So you have like a dedicated staging environment, and they have IP addresses and like DNS entries like staging.mycompany.com. So with something like Chef, because everything's captured in code, you can spin up ephemeral staging environments. In fact, I've been consulting at a company that is using EC2 spot instance pricing to minimize the costs that they're willing to pay for a staging environment, using Chef to spin up their entire production infrastructure, which I can't give you the exact number, but it's over 500 nodes, which is a server, basically. They're running all of their infrastructure tests. They're leaving it up for about maybe 2 to 3 hours. They spin it down. It costs them about 20 bucks. And that's awesome. And the amount of time and effort they put into writing this like staging environment doesn't matter, because it's the same code that they use to build their production machines. So not only is their staging environment literally a direct replica of the configuration and the implementation of their production environment, but because it's reproducible in code, they can just spin one up. And that leads into like the next thing that we'll talk about, which is cool. This is ephemeral. See, like it goes, so you get it? You guys, it starts at 100% opacity and goes to 25. I'm not a designer. Anyway, so the last thing I want to talk about is you can spin up a new infrastructure when something goes wrong. So how many people in here have a DR strategy, a disaster recovery strategy? Like 3 hands. So what happens whenever like EC2 goes down? Because that never happens. You guys are just down. You have like a nice little, we're sorry, it's EC2's fault message. Because when you're down, you're losing money, and that's not cool. So what if there was a way that like, oh shit, EC2's down, or like, oh shit, our data center caught on fire, or like, oh shit, there was a massive hurricane on the East Coast, let's move all of our stuff to the West Coast. Like right now, the way companies do that is they have two data centers, one on the East Coast and one on the West Coast, and they flip some DNS switch and they send traffic over there. But you have to pay for two data centers, and that's expensive. You may not even be using one of them. With something like Chef, you have, again, this really cool animation here, right? If your data center catches on fire, you can spin a new one up, and depending on the size of your infrastructure, it may only take 5 minutes to spin up an entirely new environment. Your entire production environment can be spun up somewhere else. And that's awesome. And whether you want to actually do this, where you want to keep running production in the West Coast data center, or if it's a temporary thing, just so you can keep serving orders or selling your product or making t-shirts or whatever drives your business, as long as you can continue putting the core of that business or producing the core of that business, you have an awesome disaster recovery strategy, and it's as close to production as possible. I'm going to say that a lot. Like, as close to production as possible is really important. OK, so let's look at scenarios. The first scenario is Capistrano, and I'm going to apologize because this is twice that I got screwed over. I gave a talk at Velocity where I had all of these awesome GitHub screenshots, and then GitHub released their new UI the morning of my talk, which was awesome. So none of my slides made sense. I made this talk last week, put finishing touches on it this week. Capistrano was at Capistrano 2 last week. It is at Capistrano 3 this week. However, hopefully none of you have used Capistrano 3 and have no idea what I'm talking about, because this is written for Capistrano 2. Awesome. So the first thing I want to talk about is cap deploy setup. Who knows how cap deploy setup works, like at the systems level? Anybody want to volunteer to explain it? No. OK, cool. So it just creates a whole bunch of directories. It's real simple. See, they're even on the slide. So it makes a releases directory and a shared directory, and then recursively creates a logs directory, a PIDs, and a systems directory. Pretty straightforward. There's a little bit more, depending on what your cap configuration is. This is cool. The problem is if you have 50 servers, you don't really know which ones you ran cap deploy on and which ones you didn't. And cap deploy is sometimes idempotent and sometimes it's not. And if you have a special script that runs after your deploy that changes a directory or maybe updates a symlink, running deploy setup, again, could actually negatively impact your application on places it's already been deployed. So there has to be a better way to do this for setting up this configuration. So let's take a look at how we might handle this with Chef. So this is Chef code. All of the Chef code will have the Chef logo in the corner. Basically, what we're doing here is we're setting up our deploy to directory. We're stealing that borrowing that semantic from Capistrano. And we're going to deploy an application called MyFace. And we have an array of directories. So those of you that are Ruby fanatics, you could also use your %w there. Be cool. Get all your quotes in white space. And then we're going to iterate over this list of directories, and we're going to use Chef. So the only thing in here that's actually Chef is this directory, what we call a resource here, or this directory call. Everything else here, even this iteration here, the each block, should look like pure Ruby, because it is. And that's the power of Chef. And you guys and girls as Ruby developers have the opportunity to use pure Ruby and do really cool Ruby things, but also manage servers with it and deploy code with it, as we'll see here. What that directory resource is going to do, and you can see that we're just putting a slash in there, is we're going to say, for each of those directories, make that directory. It's effectively the same as running mkdir on a Linux machine, but it's idempotent and convergent. And those are two words that I want to talk about real quick. Idempotent means that when it does something, it's like multiplying by 1, so it's a changeless operation. Convergent means it doesn't do something even if the result is idempotent. So makedir-p is idempotent because it doesn't do anything if the directory already exists. However, a check that says, does the directory exist, if the directory does not exist, makedir-p is convergent because it doesn't do anything. It first has that check. And Chef does both of those. Not a super important thing. If that didn't make any sense to you, don't worry about it. But it is something that computer science people really care about, because it helps with performance. So Let's talk about the directory resource for a little bit. Directory first takes a path. So the first thing is the path to the directory. And then you can optionally pass things to a block. So you'll notice in the previous example, I didn't pass a block to the directory resource. It does accept a block, and each of those blocks have like a key value type syntax. You can specify the owner, which is the person who owns that directory. You can specify the group of that directory, and you can even specify the file mode that that directory should be part of. Cool. Let's look at cap deploy. So if we want to deploy something, the way Capistrano works is it checks out the latest reference and then puts the things in a releases directory that is the current timestamp and then updates a symlink. So if we were to use Chef for doing something like this, first we grab the current time, and then we're using that same deploy to we did before. And basically, we're going to use the Git resource. Again, this is a core resource. If you were using SVN, you could use SVN. And we're going to create something at that Git directory, and we're pulling from GitHub. Hello. We're pulling from GitHub at master. In this example, I'm using a depth of 1. So these are all things that you could actually be configuring in your Capistrano deploy RB. But here we're using Chef for it, and I'm just doing a simple checkout. So what this is going to do is effectively clone at depth 1 at the ref that we give it. Then it's really simple. Just create a symlink to current. If that symlink already exists, Chef will overwrite it in this case. And then I'm assuming that you're using Passenger. You would obviously touch your restart.txt. So this is really cool. So basically what we did is we completely replicated Capistrano's setup and deploy process in pure Ruby code in a Chef recipe. So this has a couple advantages. The first is idempotency. The nice thing is that we can keep running this Chef recipe over and over and over and over again, and if the directory is already created, it doesn't matter. It's just going to keep along, move along, happy-go-lucky. The second thing is if the directory doesn't exist, or if the directory gets deleted. Like if your developers have shell access to the machine and you accidentally delete a directory, just run the Chef recipe again, and it's back in a state where it can actually function. And that's really important. The second thing is security. A lot of sysadmins don't like to give developers production access on the console for very good reasons, but they don't have a problem giving developers access to these Chef recipes. So you have the power to write Ruby to also express your infrastructure. You can write Ruby code that actually manages the production things. You don't need shell access because you know exactly what's going on. And the third thing is Chef client runs as a service, or you can set it up as a cron job or whatever. And because it runs continuously, in the event that something does get screwed up, the next time Chef client comes along, it will fix itself auto-magically. That's my favorite word. So you don't have to worry about this one thing accidentally getting deleted. It's a self-sustaining or self-converging operation. Cool. So basically what this turns into is the original cap deploy becomes git push. So developers just push code into production. Git will pick up those changes. Maybe you fire off a Jenkins job, however you want to handle that. The next time that Chef client run comes through, it's going to pull down those latest Git changes, maybe run some build script or something that you've set up, and your code is deployed. So no more cap deploy. You don't have to worry about it anymore. And that's one less dependency in your multi-dependent Rails app. Yay. Cool. How much time do I have? 6. OK. Cool. That's awesome. This is a thumbs up. So let's look at another scenario. And I'm not going to go through the actual Chef stuff this time. I just want you guys to see the code. How many people have ever gotten a new laptop and then spend 48 hours setting everything up? Yeah, y'all have done that. So what I want to do is I don't want to actually go through this, mostly because I'm running out of time, but I'll be happy to talk about it. But I wanted to show you what some stuff looks like whenever you install it with Chef as opposed to the manual process. So the first thing you should all do is install Google Chrome. That is a not so humble opinion. And if you get a brand new laptop, the first thing you have to do is open up Safari, which may or may not be located on your dock. Then you need to navigate to google.com/Chrome. And you click this button that says Download Chrome. And then you have to go to your little downloads thing in the upper right-hand corner, and you click on it. And then you click next, next, next. And then you drag the DMG into the applications folder. And it's really fun, right? And this is totally manual. Who loves to do this? Yeah, nobody. Nobody wants to do this. This is what it looks like in Chef. That's 4 lines of code. I can count those on one hand, and I'm not missing any fingers. All you do is specify the URL to the DMG package, and Chef will install it. And if it's already installed, guess what? Chef does nothing. And if you update that URL to the new version, guess what? Chef installs the new version. Let's look at another example. Blah. Firefox. Pretty simple. How about VirtualBox and Vagrant? You can see a pattern here. Installing DMGs is really, really easy. You just specify the source and the name, and Chef installs it for you. And if you uninstall it, the next time Chef runs, it installs it for you, which is both painful and awesome. All these gems, magical homebrew stuff, throw them in a list. This is what I want Homebrew to install. Done. We're installing RBM and Ruby build. What if we also had Chef build our Rubies for us in our local development environment? We can do that. I want Ruby 187, Ruby 193, and Ruby 2.0. Here we specify our item potency. We say, I don't want to install it if I already have that version. This one's really complicated because it's AppleScript, and I don't actually know if it works because I tried it and it works on my machine. But this actually tells the application finder to set the desktop picture to whatever file you give it, and this is a Ruby method. And since Chef is Ruby, you can write it as a Ruby method. And then you can throw it inside a Chef recipe down here, where you're actually running it as an AppleScript. So here we say, go download this remote file from Inger, which I'll give you a hint. This is an Easter egg if you guys want to go look at. And then we execute the setting of the background image later. So this is cool. So long story short, if you followed that, we installed a whole bunch of stuff. We configured a whole bunch of stuff. So we installed Chrome, Firefox, VirtualBox, Vagrant, Mongo, Postgres, RBM. We configured G-code graphics, 3 different Rubies, and set our desktop background. How many lines of code do you think this gist takes that I'll publish later? 50? 30? 51. No, comes in at like 120. But a lot of that is because I didn't use iteration like I did on the slide. So I'll try to get it down as low as possible, but it's less than 150 lines of code. I would be willing to bet that you would type more than 150 lines into your terminal doing this stuff.
Does that also include installing Homebrew and Xcode and all
That comes for you. So that's awesome. I know what you're thinking. How is this better than a bash script? And there's a whole bunch of reasons. It's reliable, reproducible, idempotent, cross-platform, clean, Ruby, most importantly, those 3. And now I know what you're thinking, which is, how do I get it? This is the end of my talk, so we're going to wind down now. So if you want to get Chef, you go to this awesome place called getchef.opscode.com. And if you want to learn Chef, where do you guys think you go? Learnchef.opscode.com. And if you want to be a chef, because we're hiring, and that slide just magically skipped over, if you want to be a chef, you get to go to opscode.com/blog-careers, and you get to work with me every day. And I have been told that I'm awesome. So this is my, stop it. OK, that's my slide. If you guys have any questions, I know I'm short on time because I talk a lot. But if you want to listen to me talk a lot more outside of this, you can come find me. I'll be somewhere over there.